dividing radicals, they're going to, in general, give you questions like this where you're going to have to apply one of two different rules in order to solve, but they're both pretty easy. So the first thing is you're looking for perfect squares that can be, you can take the square root of. And if you don't have those, you're going to want to try and divide them first. So the square root of 100 is a perfect square, and the square root of 25 is as well. The square root of 100 is 10. The square root of 25 is 5. 10 divided by 5 is 2. And we're done. All right, let's look at the next guy. Square root of 36 over 64. So if you do 36 divided by 64, you're going to get this weird number here, and then if you hit the square root sign, you're going to get this. And this isn't what they're looking for. They're not wanting you to write it as a decimal. They're wanting you to write it as a fraction in simplest form. So is there another way to do this? Absolutely. You're going to take the square root and you're going to put it on the 36 and the 64. So underneath radical 64. And the square root of 36 is a perfect square. That's 6. Square root of 64 is 8. And so this is pretty good, but we can even make this even a little more simple. If I do 6 over 8 on my calculator, that's 3/4. It's going to simplify it for you. 3 over 4. Okay, now that isn't always going to work. So if I take the square root and I put it on the 32 and the 8 like I did in my previous problem, it's going to mess up. So instead, why don't we do divide it first? Let's see if we can get a perfect square out of dividing it. 32 divided by 8 is 4. Now we can take the square root of it. It's actually going to be 2. So square root of 4 equals